Hello and welcome back to another lesson. In today's lesson, we are going to focus our attention on multiple regression. We are going to build off of some of the concepts that we learned in prior lessons. We're going to look at what a multiple regression equation will look like and specific language we should use when interpreting multiple regression. We'll also continue to build on binary variables and the language that we should use when interpreting binary variables, because there are some important differences that we will use when we are writing our interpretations. We're also going to look at several different examples in the video for what that might look like. And with that, let's go ahead and hop on over to our lesson. So we are going to start with a made-up example with some made-up numbers, and we're going to go back to simple regression with this, and then we'll use this example to build off of this as we go into multiple regression and talk about interpretation. So just so you know, this is not going to be to scale and everything is made up, but hopefully it will serve as an illustrative point of how this works graphically or visually, and then starting with simple regression and moving on to multiple regression. And that's one of the goals of the video for today. So first, just as a reminder, this is what our equation looks like for simple regression. So hopefully that looks pretty familiar to you by this point. As a reminder, this is your intercept, and then this is our slope and our independent variable and our error term. So I'm going to just put up some made up numbers, and then we will take a look at what we have going on here. So for my equation, I have the y hat, and so remember that I can drop the error term, and in place of my intercept, I put a 70, and then I have my coefficient here as 3.53, and then the x is representing our independent variable. So let's go ahead and look at what we have on the graph. So as a reminder, this is our y-axis and our x-axis. So along our y-axis, which is our dependent variable, is a grade. Let's just say it's a grade for an assignment or for a class. And then down here on our x-axis, we have the hours studied. And so what this is telling us is that if we have a 0 here, that we studied 0 hours, it would cancel this out and we would be left with 70 as our intercept. So our line would go through the 70 like this. That would be where our intercept would go. So I'm going to just draw a completely imaginary line that, like I said, well, the line is not imaginary. I'm going to draw a line that the slope is not going to be to scale. But let's just say that our slope is that 3.53. So what that's telling us is that for every additional hour studied, our grade will go up by 3.53. And so that should make sense, because this line, what this line is showing us, the more hours we study, the higher our grade will become. And then the addition should also alert us to that this is going to be a positive relationship. And so we would be moving up the scale by this 3.53. Okay, so hopefully all of this feels familiar to you, and all of this feels like maybe a little bit of a review. Let's just, for the sake of one more thing, go ahead and add a number here. Just to demonstrate it. So let's put as our x, let's say that we studied for 5 hours. So we would say 70 plus 3.53 times 5. We work that out, and our total is 87.65. And so if we studied for 5 hours, our final score would be 87.65. For the sake of this lesson specifically, which we're thinking about the words that we would use to interpret, we would say that for every additional hour studied, the grade would increase by 3.53. So that's how simple regression works, and that's how simple regression works when we are working with continuous variables. So it's going to change slightly when we are working with binary independent variables that we talked about last lesson. So let's go ahead and look at what that would look like and how our interpretation changes with that. So as a reminder, when we are working with binary independent variables, we are dealing with things like yes, no, male, female, agree, disagree, things like that. So it's binary, there can only be 2 options. So in this case, this information that I'm going to use is actually from the data set that is, I believe, available to you with the marathon race times. I'm just going to use it as a point of illustration for the interpretation. So in this case, our female is going to be 1 and our male is going to be 0. For this, we would have our race time, and we're going to put our hat because it's an estimate, is 195 plus 36.429, and then in this case we are going to have our female here. So again, this is our intercept, this is the coefficient, and this is our x value, or our independent variable. So notice our female is 1. So if we are going to put this into an equation, we would have 195 plus 36.429 times 1. So let's go ahead and multiply that out. So when we work that out, it would be 231.429, and this is in minutes. So that's how many minutes it would take on average a female to finish this marathon. So for male, we're going to put our x as 0. So then it will get rid of our slope, and now we're just going to be left with this. So a male's finishing time on average would be this 195 minutes. So we can't say, when we interpret, we can't say that for every 1 unit of females or for every 1 unit of males. That type of language doesn't make sense when we're working with this type of variable. So when we are working with these binary independent variables, we're making a comparison between two groups. We would say on average it takes females 36 more minutes to finish a marathon than it does for males. Hopefully that adds some clarity of the different language that we use when we're interpreting different types of variables. So now that we have just a quick review of that, let's go ahead and look at what multiple regression would look like and how we slightly change our language for that. Here's an example of what an equation for multiple regression would look like. So let's go ahead and just break it down a little bit. So we still have our y with our subscript. We still have our beta naught, which is our intercept. And then we have our beta 1 with x 1i. So this is the slope for our independent variable that goes with this one. Okay, so then we have b2 and then x2i. And so this is our independent variable and our coefficient that goes with this independent variable, and so on. So we can have as many as we need. The other thing is, let's go back to our example that we started with where we talked about grades and hours studied. So let's say that this independent variable is going to go with hours studied. This independent variable is maybe going to go with attendance. This independent variable maybe is going to go with how many vitamins you take every day. And maybe this independent variable is going to go with interest. So now you have multiple variables that you're looking at. And again, this is going to be your final grade. So now what you're doing is you're looking at how all of these different variables are going to affect your dependent variable or your final grade. And so the language that will change slightly is that you will say, let's just stick with the hours studied. So now you would say that for every additional hour studied, your grade will increase by 3.53 points, holding all other variables constant. So once you start adding other variables, the language of your interpretation must include that last part that says holding all other variables constant. Notice that these are all continuous variables, and then interest, for the sake of where we're at right now, and we're just thinking about binary, let's just say it's interested or not interested in math. And that can account for this because when we do our interpretation, we interpret one variable at a time. And so for our interest, we might say on average students who are more interested in mathematics score higher on their final grades than students who are not interested, holding all other variables constant. So in your equation, it does allow for both your continuous and your non-continuous variables because your interpretation will include one variable at a time, and you just need to make sure that you're using the appropriate language for the type of variable you have and that you are ending it with the term holding all other variables constant. All right, that's it for this part for now. We're going to go ahead and head back over to the PowerPoint and look at a couple more examples over there. Now let's look at this example that is found in the PowerPoint in the notes for the class. So in this case, the research question is, what is the relationship between the number of AP credits earned in high school and a student's college GPA? So our dependent variable, of course, is the college GPA, which can range from 0.0 to 4.0. And the independent variable is the number of AP credits that a student would take, from 0 credits to 15 credits. And so we already have the output of this. We ran it through SPSS, and this is our output. So the constant, or the intercept, that B naught in our equation is that 2.449, and that our coefficient for the AP credits is 0.097. So remember that when we are making interpretations, we want to look at both the coefficient and then also the significance level, because if it's not statistically significant, then it's not something that we would report. We're not going to go much further than that. And in this case, we can see that it is statistically significant. So what we can tell by this is that the more AP credits that someone takes, the higher their GPA in college would be. With this information, a logical conclusion might be that everybody should take AP credits because they would end up with higher GPAs in college. But there is likely more to the story. And in this case, we're only looking at one variable. And so again, because we're really thinking about multiple regression and multiple variables, let's go ahead and see what happens when we add an additional variable. This time we added the ACT score. Now let's look at what happens to everything. So let's start at the bottom and work our way up. So the ACT score, our coefficient is the 0.106, and it is statistically significant. But notice what happened to our AP credit score. It actually dropped by a lot. So, right, remember, if we look at the other screen, it was 0.097. And when we added that additional variable, it dropped our coefficient to 0.002. Notice also that it is no longer statistically significant. And so the problem, we can go back up to the very top, and it says the problem is that there's other things that are related to both AP credits and a college GPA. So it's likely that much of the relationship between AP credits and a college GPA is due to just being a good academic student in general, or maybe there's other factors that we haven't looked at in this as well. So our solution is that we need to control for a third variable, and we control for that by using our ACTs. So let's go ahead and think about some problems that this can cause. And the problems mostly that is called is omitted variable bias. So I'm just going to kind of read off this slide and we'll talk about it a little bit. So if we don't include a measure of academic ability, in this case it was ACT, in our analysis, we can reach the wrong conclusion about the relationship between the variables we're looking at. And this is because academic ability in this case helps to explain both the number of AP credits and a college GPA. High ability students, people who have high ACT scores, are more likely to take the AP class and therefore are also more likely to earn higher GPAs. So our coefficient on AP credits would be biased if we didn't include a measure of academic ability. So for that, some questions that we commonly get are, how do you know which variables should be included? And the answer to that is really your literature review. So the more you know your dependent variable, the more you should know and understand the independent variables that should be looked at. And you find that out by doing a good literature review and by looking at other studies. How are other studies looking at your construct of interest? And are you including variables that they included, and why or why not? And those are things that you should be able to articulate. If you choose to omit certain variables that other studies related to your dependent variable, if you choose to omit those, then you need to explain why. And that should be somewhere in your paper. But for the most part, if it's something that is common knowledge, in this case, that high achieving students would likely score high on things like the ACT, then that really should be included in your college GPA. or SAT, either one is fine. But those are things that we would expect to see contributing to our college GPA based on what the literature has told us. And so the answer to the question is really, you're going to find out which variables should be included in your regression based on the literature review. So when we omit these variables, it's a spurless relationship, which I believe you have talked about before. So we're going to look at it one more way. So we have our omitted variable bias, is what we're still thinking about, where we have other independent variables, and we have our independent variable and our dependent variable. So when we examine the relationship between x and y, we need to be sure that there aren't any unaccounted for z variables. Okay, that could relate to both of them. And so in that case that we just looked at, that ACT score is this independent variable that's going to relate both to AP as well as college GPA. And so if there is some z variable that exists, it needs to be in our regression model. And if it is not, then that is a way that bias can creep into our study. Let's go ahead and take a look at one more example. So in this case, the research question is, what's the relationship between one's company experience and their wage? So our dependent variable is the hourly wage, and the independent variable is years of experience. So by just looking at one independent variable, years of experience, we would see that it is a positive relationship. So the more years you work, the higher your hourly wage, and our coefficient is 0.049, and it is statistically significant at the 0.05 level. But there are likely several more factors that would contribute to somebody's final wage, and so in this case we're going to look at just one more. One additional factor is the region of where you live. And so in this case, this person might live in the South. And so that's going to be placed as a binary variable, South and then everywhere else. So here we can see in this case, there weren't a lot of changes. Unlike when we looked at AP scores and college GPA, we noticed that when we added that extra variable, there were a lot of changes. But in this case, a lot of it has stayed relatively stable. So our coefficient for years of experience is still 0.049. It is still significant at the 0.05 level. And then our new variable is lives in the South. So remember, this is telling us that it's a control variable, that it's binary, which means that we're looking at lives in the South versus lives in other regions within the United States. We see that it is negative, which means that there's a negative relationship. And so people in the South are typically going to make less money compared to people who live in other regions in the US on average. And of course, we see that it is statistically significant. So thinking back to the beginning of our lesson where we talked about how to interpret binary variables, in this case, we would say something to the effect of, on average, people living in the South make $2.25 or 26 if you want to round, dollars per hour less than people who live in other regions of the US. So this is just an example that sometimes adding those extra variables, it changes our variable of interest quite a bit, and other times it doesn't change it too much. But the important thing is that we need to remember to include all important variables to our topic of interest and to our construct, and we really do that through a very good comprehensive literature review. Hopefully that helped you out and gave you some more resources to consider and the proper language to use when interpreting and specific things to look out for when you're doing your own research. So best of luck, and we'll see you in another video very, very soon. Bye for now.